learn today. First, limit notation. So suppose you have to graph this function, like on last night's homework. 2x minus 1 over x plus 1. I think that's the same example I did on the board yesterday. I'm just going to draw it really quickly. X-intercept 1/2. Y-intercept -1. Vertical asymptote x is -1. Horizontal asymptote y equals 2. So the graph looks like this. It's basically a hyperbola. Okay, but now you got to learn limit notation. What is the limit? Have you seen this before? You had to have if you took algebra 2 classes, right? How did you learn about the number e? Because next chapter we're going to learn about the number e. How did you guys learn about the number e? Okay, never mind. Okay, so the limit as x approaches infinity means when x is really large positive, like when x is a million, a billion, a trillion. In other words, as the graph is going out to the right, the y coordinates are getting closer to what? Look at the graph. As the graph is going out to the right, the y coordinates are getting closer to what number? 2. And why is that? Because that's the horizontal asymptote. This is how we describe asymptotic behavior. What is the limit of this function as x approaches negative infinity? In other words, when the graph is going out to the left, the y coordinates are getting closer to what number? 2, because that's the horizontal asymptote, right? What is the limit of this function as x approaches -1 from the left side? Okay, here's x equal -1. There's a vertical asymptote. As I approach from the left, look, the graph is exploding upward. What can you say about the y coordinates? They're getting infinitely large, right? So what do you think it is? What is the limit, do you think? It's infinity. Because the y coordinates are just getting infinitely large without bound. What is the limit of this function as x approaches -1 from the right side? Okay, so here's -1. Coming from the right, look at the graph. The graph is exploding downward. What do you think the limit is? Negative infinity, because the y coordinates are getting really big negative, right? Without bound, negative infinity. So this is how we describe asymptotic behavior. We use this limit notation. So just by looking at the graph, it's really easy to figure out limits, and that's all you have to do on tonight's homework. You just graph and you look at the graph. So if they ask you what's the limit as x approaching infinity, you look what's happening to the graph as it's going out to the right. What's the limit as x approaches negative infinity? What's happening to the graph as it's going out to the left? And then this is how we describe behavior around a vertical asymptote. What's the limit as x approaches -1 from the left? Well, you just look. If it's exploding up, the limit is infinity. If it's exploding down, then the limit is negative infinity. Very simple. Okay, next thing we're going to learn is how do you graph things with slant asymptotes? Now, I know you guys did this last year. So let's do an example. Y equal, let me think. How about x minus 1 squared all over x plus 2? No, I want to change that to x plus 1. Probably make it nicer. Okay, so the first thing you want to do is multiply it out. X squared minus 2x plus 1 all over x plus 1. But you want to put it in this form first, because then if you can cancel stuff, you cancel it, right? And then you get the removable discontinuity. But since nothing cancels here, no removable discontinuity. So you still go through the same 4 steps we learned yesterday. X-intercept. What makes the top 0? Really? 1. Y-intercept. Plug in 0 for x. I think it's easier to look at this one. Plug in 0 for x. 1. Vertical asymptote. When is the denominator equal to 0? So x equal -1. Now, is the degree of the top and the bottom the same? No. Is the degree of the bottom bigger? No, the degree of the top is bigger. So that means there's no horizontal asymptote. But there's going to be other types of asymptotes. If the degree is bigger by 1, you get a slant asymptote. It's a line. But if the degree at the top is bigger by 2, then what you're going to get is a parabolic asymptote. You guys never learned that one last year, right? Just the line. If the degree is bigger by 3, then you're going to get a cubic asymptote, and so forth and so forth. But luckily for you, I'm only going to make the degree bigger by 1, so it's just going to be a line. We'll call that a slant or an oblique asymptote. Now, do you guys remember how to find the slant asymptote? You actually have to divide, because that's what this means. So, what happens when you divide this by this? You want to do long division or synthetic? It's up to you, it doesn't matter to me. I'd rather do synthetic because it's a shortcut. Okay, so if I'm going to divide by x plus 1, what do I put in the box? Negative 1. Okay, so do synthetic division. 1, negative 1, negative 3, 3, 4. Did I do that correctly? So what does that stand for? When you divide this by this, what do you get? What does this stand for? X minus 3, the quotient, plus the remainder over the divisor. That's what you get. Okay, now look at this. What happens as the graph goes off to the right and to the left when x is a really large positive or a really large negative number? What happens to this? What happens if x is like 1 billion? 4 over 1,000,000,001, that's practically 0, right? So we say that as the graph goes out to the left and the right, this will get closer and closer to 0. So what's left? Yeah, this. So the quotient, you see this quotient right there? That is the slant asymptote. So do we know how to graph the line y equal x minus 3? I hope so. So this is y equal x minus 3. Now this is kind of like the horizontal asymptote. This asymptote only takes effect out here when the graph is going out to the right and to the left. So when the graph is going out this way, it's going to start getting closer and closer to this slant asymptote over here. Okay, so here we go. So to the left of this vertical asymptote, is the graph going to be up here or is it going to be down there? And please don't do both like last year. It can't be both because then it's not a function. So it's either up here or down there. What are the clues? It has to be down here. How come? Why does it have to be down there? Because if it were up here, there would be an x-intercept. It would cross the x-axis, but there is none, so it has to be down there. And if you're really, really unsure, how about like plugging in -2 or something? But we don't want to do that. And then look at the denominator, first power. So if the thing is exploding downward on this side, what do you think on the other side? It's exploding up. Okay, now I go through the y-intercept. I'm coming up to the x-intercept. Do I go through or bounce off? You bounce off because even power, right? Bounce off. Now what do? I don't know what to do, Mr. Park. You get closer to the slant asymptote. If the graph is going out to the left and to the right, that's when either the horizontal or the slant asymptote starts grabbing it. And there you go. That's how you graph things with slant asymptotes. So if the degree of the top is bigger by 1, you're going to get a slant asymptote. Okay, so since the quiz took so long, we're going to do the abbreviated version. Oh. Okay, so look at number 5. You have to write a rational function, and I'm going to tell you what the asymptotes are. So I'm going to tell you what a function is, and then you have to write what that function is. I'm going to show you the fastest way to do it. Okay, I don't want to do the same thing. So vertical asymptote is, how about x equal 2? Slant asymptote is y equal, how about 2x, just use a different number, x equal 3 and 2x minus 1. And then what else do I have to give you? This one has a removable discontinuity. I'm not going to do that. I'll just say it passes through the point. Give me something. It passes through the point, how about 1, 4? See how I just use the numbers 1, 2, 3, 4? Okay, so So you can kind of sketch it if you want, but you really don't need to if you know what's going on. If you have a vertical asymptote at x equal 3, doesn't that mean you need x minus 3 in the denominator? If the slant asymptote is 2x minus 1, like this is the thing here. How do you get the slant asymptote again? You do long division. And when you do, well, it doesn't have to be long division. You just do division. And what do you get? You get the quotient plus the remainder over the divisor. So anytime you have a problem with a slant asymptote, just do this. It's really easy. So y, don't forget to put the y equal. So you're going to have the quotient plus the remainder over the divisor. That's what happens when you divide, right? Isn't the slant asymptote the quotient right here? Remember? Like when we divided. Isn't the quotient the slant asymptote? So whatever the slant asymptote is, just put it right there. If the vertical asymptote is x equal 3, doesn't that mean you need x minus 3 in the denominator? And then the remainder, we don't know what the remainder is, Mr. Park. Well, let's just call it r, or whatever letter you want to call it. I'll put r for remainder. Now, is there a way I can figure out what that remainder is? Yeah, I gave you this point. It passes through the point 1, 4. So what do you think I'm going to do? You plug it in. And then you're going to get 4 equals, can you guys plug in 1? 2 minus 1. Plus r over 1 minus 3. Can I solve for r? Yes. Otherwise I wouldn't make this problem, right? 3 equals r over negative 2. That means r equals, hello, that's the easy part right there. Negative 6. So now that we know the remainder is negative 6, that means the equation of this, whatever this graph is y equal 2x minus 1 plus negative 6 over x minus 3. Should I leave my answer like that? No, because on the quiz, you're going to have to put it in rational form, like polynomial over polynomial. So how do you do that? You make a least common denominator. So let's do this quickly. I guess this is the last problem we have to do. So you got 2x times x minus 3 minus 1 times x minus 3 minus 6. Multiply it all out, you want to get 2x squared minus 6x minus x plus 3 minus 6 over x minus 3. Final answer is 2x squared minus 7x minus 3 all over x minus 3. That's it. So just remember, anytime you have a problem with the slant asymptote, just do what I just did here. Quotient plus remainder over divisor. Okay, now tonight's homework problem though, it says, instead of passing through this point, it says, this point is a removable discontinuity. Well, you would do exactly the same thing, except at the end, what would you do? What has to happen when you have a removable discontinuity? You gotta cancel out stuff, and since if this is a removable discontinuity, then what do you go, x minus 1 and x minus 1 then? Because that's where it is, and x is 1. So you just have to do that one extra step. Now, look at this problem before you go. We don't have time, I can't teach you that, so watch the video, or I think it might be in the notes. Okay, we're done. So I guess period 4 is not going home early today.